Hey everyone, welcome to today's Explainer. I am so incredibly pumped you're here with us. Think of this session as your official Day 1 orientation, a complete roadmap to mastering the technological future. We're going to unpack the architecture and the core building blocks of edge computing. Now I know it sounds a little complex, but by the end of this, you're going to see exactly how these concepts are shaping the modern world, and honestly, your everyday life.
Okay, let's dive into this curriculum map. We'll kick things off by welcoming you to the edge, figure out how it powers tomorrow's apps, and then master distributed systems. After that, we're bringing cloud and IoT together before wrapping up with the big challenges, federation, and, most importantly, the incredible career opportunities waiting for you.
So, Section 1, Welcome to the Edge, Foundation and Objectives.
To kick off our journey, we really need to understand the core objectives of this infrastructure. Edge computing architecture. It's not just some abstract code floating around out there in the ether. It is the fundamental structural design, literally the building blocks, needed to support real-world infrastructure. You know, imagine a smart traffic light that instantly adapts to let an oncoming ambulance through. That needs edge architecture. And the overarching objective of this entire design? It is completely built to support user applications. Keep that as your guiding star today.
Right, so identifying the objectives of edge computing architecture to support user applications, it's super easy to look at academic texts like this and just see dry theoretical stuff. But if we play the so what game, we quickly realize these aren't just academic hurdles to jump through. They are the actual, literal blueprints for modern technology. Knowing this stuff means knowing how the critical, everyday systems all around us actually tick.
Moving right along to Section 2, Powering Tomorrow's Applications, Edge in Action.
Now, what's really interesting here is comparing these two real-world examples. We established that the whole point of this architecture is to support user applications, right? But what does that look like out in the wild? Well, on one hand, you have 5G slicing, which is all about carving out dedicated, super fast network lanes for critical data. Contrast that with self-driving cars, which are trying to navigate chaotic physical streets in real time. Both of these rely 100% on the edge computing architecture we just defined. We're not talking about minor tech upgrades here. We are talking massive real-world stakes where data absolutely has to be processed right where the action is happening, instantly.
Which naturally leads us to a pretty massive question. If we have these crazy high-stakes applications, like literally autonomous vehicles hurtling down a busy highway, how do distributed systems actually make them possible? Like, how do you coordinate all that data without a single central brain doing all the heavy lifting?
Well, let's figure that out in Section 3, Mastering Distributed Systems, Time and Snapshots.
Mastering these fundamental concepts is the next major milestone on our map. When we talk about applying the concepts of distributed systems in edge computing, we're talking about the crucial mechanics. Distributed systems are basically a network of independent computers that act like one single, coherent brain to the user. They are the engine under the hood that makes the edge and those self-driving cars actually viable. And to master them, we've got to look at two very specific concepts: clock synchronization and the distributed snapshot.
Let's break down the timing, because it is wild. Imagine an edge node initiates an action. We are operating in absolute milliseconds here. By millisecond 2, we need total clock synchronization across the whole system. And by millisecond 3, we achieve precise time ordering. Again, let's ask, so what? Well, if a self-driving car's sensors aren't perfectly synced down to the literal millisecond, the system doesn't know what happened first. To put that into perspective, at highway speeds, a car travels over an inch in a single millisecond. Without precise time ordering and clock synchronization, that car simply cannot function safely. We're talking life and death managed in fractions of a second. So the crucial point is that understanding time naturally leads us to the distributed snapshot. Since these systems are completely decentralized and moving incredibly fast, we need a way to capture a consistent global state of the entire edge system at one specific point in time. It's kind of like taking a massive panoramic photo of a moving crowd, but everyone is frozen perfectly in stride. Capturing the snapshot is a super critical puzzle piece in actually mastering distributed systems.
All right, zooming out a bit for Section 4, Integrating Cloud and IoT, Building the System Model.
Let's move on and see how this all builds together. Step 1 is our foundational layer, cloud infrastructures. Step 2 brings in the IoT platforms, the Internet of Things, which is basically all those connected smart devices out in the physical world. Finally, Step 3 layers in the edge infrastructures we've been geeking out about. Stacking these 3 layers creates the complete system modeling framework we need.
System modeling is essentially taking cloud,
IoT, and edge, and integrating them into one massive unified architecture. Unpacking the complex relationship between these three distinct layers is absolutely vital if you want to understand the full edge computing ecosystem. They don't just operate in their own little bubbles. They constantly feed into and support one another to create this incredibly powerful, seamless network. And that brings us to our final destination, Section 5, Challenges, Federation, and Careers, the Final Frontier.
This is the moment where theory crashes right into your future career. So, what are the research challenges in federating edge resources? Seriously, think about this for a second. Applying different edge computing models to federated resources, meaning resources that are physically scattered everywhere but still need to be connected and governed together, that introduces an insane amount of complexity. I mean, how on earth do you share power, maintain tight security, and sync data seamlessly across completely different organizational boundaries?
Identifying these current trends and challenges in edge computing infrastructure is exactly what the industry is desperate for right now. Currently, tech giants are facing massive hurdles in scaling this stuff, locking down security, and making it all interoperable. The people and organizations that actually solve these infrastructure challenges, they are the ones who are going to completely define the next decade of global connectivity.
And this brilliantly illustrates our ultimate goal here, because when you actually master these concepts, when you can identify career paths, model unified architectures, apply distributed system concepts, and discover industry opportunities, you directly unlock incredible career paths. You stop being just a passive consumer of technology, and you become an active architect of it, armed with the exact skills that top-tier companies are practically begging for right now.
So I'll leave you with this one final thought. Will you be the one to solve the research challenges of federating edge resources and architect the infrastructure of tomorrow? The roadmap is right here in front of you. The foundational building blocks are in your hands, and honestly, the career opportunities are limitless. It is time to take these concepts and make them your reality. Thank you so much for joining me on this explainer, and I absolutely cannot wait to see what you build at the edge.